Now, a freely falling body, freely falling body passes through 2 points, 2 points A and B at at distances H1 and H2 from the start. From the start. From the start. Then the time taken by it time taken by it to move from A to B is T is equal to square root of 2H2 by G minus square root of 2H1 by G. So that is square root of 2 by G into root H2 minus root H1. So seconds. This is what we have to solve. So how do we solve this? Is a very simple question. See, this is the top portion. So this is the start. This is the free fall condition. Now it has reached this point. Let us say this is H1. And from here to here, this is the point A. And this is the point B. This is the height of H2, the point B. Now it is very simple. How to calculate H1? H1 is minus H1 is equal to half GT square, minus half GT square. This we have done. Here, reaching point A, TA anukundam. So half TA square. Alage, so you get TA is equal to square root of H2 H1 by G. Same way you get TB as square root of 2H2 by G. This we solved yesterday. So TB minus TA, when you do, this is what you get. Square root of 2H2 by G minus square root of 2H1 by G. So square root of 2 by G, when you take common, square root of 2 by G, you have to take common. You will get root H2 minus root H1. Time is measured in seconds. So the answer is in seconds. Clear? This is TB minus TA. They called it as T. I hope it is clear. Note it down. Clear?
That's
Very good. Now I'll go ahead. Now, question number 2. A stone is dropped, is dropped. A stone is dropped into a well, of depth h, into a well of depth h. The sound of the splash, sound of the splash, sound of the splash is heard after a time of, is heard after a time of, is heard after a time of t is equal to square root of 2h by g plus h by v sound. So this is very easy. Suppose we have a well, now consider a well, okay, this is a well, and now the thing is that this is the water. From the top, this water is at a height of h, and now the stone is dropped like this. When the stone is dropped like this, what time it will take to hit it? So that is the t1 time it will hit it. That is square root of 2h by g. Just now we solved. Suppose if the h is the height of the well, height of the depth of the well. So that is first part, that is t1. And now t2 is after hitting the water, splash sound వస్తుంది మనకి. There will be a splash of sound, splash of water, right? That splash will be, that sound will be traveling upwards, okay, in some time t2, let us say t2 అనే టైంలో ఇది పైకి వెళ్తుంది. We know how to calculate the time h. So the t2, the velocity of sound is equal to h by t2, speed equal to distance by time. So we can use t2 is h by v sound, right? So the time it takes అంటే మీరు ఈ స్టోన్ అని వాటర్లో డ్రాప్ చేసిన తర్వాత మీకు ఎంత టైంకి మీకు స్ప్లాష్ సౌండ్ వినిపిస్తుంది అనేది క్వశ్చన్. సో ఇట్ టేక్స్ ద టైమ్ ఫర్ ద స్టోన్ టు reach the well top and the time for the sound to reach your ears. Both the things you have to calculate. అంటే ఇది వెల్ యొక్క వాటర్ని హిట్ చేసే టైము ప్లస్ సౌండ్ మీ చెవులకు రీచ్ అయ్యే టైము, ఈ రెండు యాడప్ చేస్తే దిస్ వాట్ యు గెట్. సో టీ ఈజ్ ఈక్వల్ టు టోటల్ టైమ్ ఇస్ t1 plus t2. So that is square root of 2h by g plus h by v sound. I hope clear how to do this.
Noted, sir.
Very good. Now, the next one. Third, this is a point you have to remember. If two bodies are held one above the other, if two bodies are held one above the other, separated by a distance of s, separated by a distance of s, separated by a distance of s, and released simultaneously, and released simultaneously. The distance of separation, the distance of separation, the distance of separation between them remains yes, okay, throughout the motion, throughout the journey. Throughout the motion or journey. Clear? Written?
Yes, sir.
Okay. Now, the next one. Vertically projected body. Vertically projected body. What is vertical projection? Vertical projection ante enti? So it is like, you see, we are standing on the ground. Okay. We are standing on the ground. And from the ground, you will project the body upwards like this. From the ground, you have projected it upwards with a velocity u. Okay. A body or particle is projected upwards with a velocity u, Now it is projected with a velocity of upwards with a velocity u. It's like this. You just throw one object up. Now, what happens? Acceleration due to gravity is always minus g. You have to remember, gravity acts always downwards. A is minus g. Now at certain point called maximum height, the body or particle, okay, stops and falls down. Okay na? I hope I am clear. ఒక హైట్ దాకా వెళ్ళి అక్కడి నుంచి కింద పడిపోతుంది, అంతే కదా? Everyone knows this, right? So this is the condition. So it will reach a maximum height and then it will fall down. It will fall down. And this is called H max. When it reaches the maximum height, the final velocity is 0 at maximum height. At maximum height, final velocity is 0. These are the things you have to remember. Clear, everyone? At maximum height, final velocity is 0. Initial velocity is u. Acceleration is minus g. So we have to write the equations of motion for this.
Noted, sir.
Very good. Now we'll go ahead. So for this condition, how to write the equations of motion? So it goes like this. Now we'll write v is equal to u plus at. What is v? I told you final velocity at the maximum height for upward motion. Let's write for upward motion. So I will write here first upward motion. Okay, let's designate. For upward motion, we'll write v is equal to u plus at. What is the final velocity? 0. So that is 0. U is upwards, so u is fine. So 0 is equal to u, but acceleration is minus g. Minus g, we will write this is ta. We'll write ta means time of ascent. Okay, time of ascent. Time of ascent. Time of ascent. Okay, so the ta happens to be u by g. I hope I am clear. So this is the equation 1. From the first equation, we got time of ascent. Second one, s is equal to ut plus half at square. S is equal to ut plus half at square. So what is s here? H max. We are measuring H max which way? Upwards, right? So s is H max is equal to ut. What is t here? U into t is ta minus half g ta square. Like this we can write. Now any height h during the upward journey, any height h at time t is given by ut minus half gt square. In fact, you want h max, it is like this, uta minus half gta square. This is h for any time t. 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 H is equal to ut minus half gt square. This is h for any time t. సో ఏ హైట్ కైనా మనం ఏ టైంకి రీచ్ అయింది అనేది కనుక్కోవచ్చు యూజింగ్ దిస్ అబోవ్ ఈక్వేషన్. దిస్ కెన్ బి ఎనీ హైట్. బట్ హెచ్ మ్యాక్స్కి మాత్రం యూటీఏ మైనస్ హాఫ్ జీటీఏ స్క్వేర్. మరి టీఏని సబ్స్టిట్యూట్ చేస్తే ఏమైనా వస్తుందా? యా, యూ విల్ గెట్ ఎ వెరీ గుడ్ రిజల్ట్ నౌ. సో దట్ విల్ సీ. కెన్ ఐ క్లియర్? వన్స్ నోటెడ్.
Noted, sir.
Very good. Now we have TA is equal to U by G. H max is equal to, what do we get? UTA minus half GTA square. TA is equal to U by G. Let's substitute. What do we get? U into U by G minus half G into U square by G square. This is what you get. G gets cancelled. So you get H max as U square by G minus U square by 2G. So this would be U square by G. Let's take common. U square by G mere common this way. 1 minus half is what you get. What is 1 minus half? Half. So H max happens to be U square by 2G. So this is the equation for H max. Please note it.
Noted, sir.
Very good. Now we have some few more things. Time of ascent TA is equal to time of descent. That is TD. Both are equal to U by G. Time of flight. Time of flight, that is TF, is equal to TA plus TD, sorry, TA plus TD. So this is U by G plus U by G, which is 2U by G. This is the time of flight. Okay. Now there is one question. Show that H max is equal to GTF square by 8. దీన్ని T అని కూడా పిలుస్తారు. You can take it as T. So sometimes they will give it as GT square by 8. We had to prove this. H max is equal to GT square by 8. We had to prove this. Clear?
Clear, sir.
Good. Now let's see the question. show that H max is equal to gt square by 8 if t is time of flight. So it's very simple. Time of flight is 2u by g. H max is u square by 2g. Okay. And now let us write what is t square. T square is 4u square by g square. Okay. Right. 4u square by g square. Now H max is u square by g. Now what we have to do is divide these two. H max divided by t square. Let us find this. So I get u square by 2g whole divided by 4u square by g square. This is what I got. U square is gone. For 1g is gone. So topple the fractions. I get h max by t square is equal to, I get g by 8. So t square you send to other side, it's very simple. H max you got it as gt square by 8. This is one way, method 1. Method 2 is there. There's one method. Method 2 is simple. You will write it as gt by 2. You can be written as gt by 2. This you go and substitute here. This is the method 2. Okay. So when I substitute that, H max is equal to, U is gt by 2. So it is g square t square divided by 2 square. That is 4 into 2 into g. So gg gets cancelled. So you get gt square by 8. You can do whichever the way you like. So I told two methods. You can do whichever the way you like, no problem. Okay. You can do whichever the way you like.
Clear, sir.
Okay, now another point. Speed at any point of ascent is equal to speed at the same point of descent. Speed at the same point of descent. Now, how to do that? The meaning ఏంటి first we'll see. So let us say you have projected up one particle. Okay, you have projected up here. Let us consider a point x in the journey, and now it has reached a height of h. This total height is capital H. Okay, total height is capital H. Total height is capital H. Now it has reached from the bottom, it has reached this height of small h. Now what is the remaining thing? H minus small h, right? This is the remaining. Now it is projected with the velocity of u. And now how to calculate this h? H is equal to, you can write ut minus half gt square. This is height at any given time. Okay. And now this is what you get. H is equal to ut minus half gt square. This is how you can calculate. And now we have to see not just this, and we have to see the velocity at this point. Velocity at this point is given by v is equal to u plus at, u minus gt. You can do like this, u minus gt. That's how one can calculate v. V is equal to, at this point, v is equal to u minus gt. So let us say Vx. And now when it goes to the top, okay, now, and then it will fall down from the top and then it will reach at this point. This velocity will be the same as this velocity. That's what we have to prove. So from this point it will fall, and I should say v dash x is same as the Vx. Now v dash x is the initial velocity. During the fall, initial velocity is 0. So when it coming down, the initial velocity is 0. So v dash, it is measured in the negative direction. So minus v dash is equal to minus g. Now the time is different. So let us say t dash is the time. Okay. What is the connection between t dash and t? This is what I will tell you, how to connect these two. That is one thing. So v dash x is equal to gt dash. These, I would say that these two are equal. So vx upwards is equal to v dash x downwards. So this can be done by using the energy conservations. Energy conservations is easy ostundi. But anyway, we'll derive this in the next class. How to do this in the next class. Okay. For now, you just note this. This is what it is. Okay. But all of you can give a try how to deal with this. Time of flight use చేసి చేయొచ్చు. Try it out. Oh, sorry. Total time of ascent మీకు ఐడియా ఉంది కదా, the time of ascent. So time of ascent minus t అలా తీసుకోవచ్చు మీరు. So what is this t? ఈ జర్నీకి ఎంత, మళ్ళీ బ్యాక్వర్డ్ జర్నీకి ఎంత, అలా క్యాలిక్యులేట్ చేయొచ్చు. సో టైమ్ ఆఫ్ అసెంట్ మైనస్ టీ పడుతుంది ఇక్కడి నుంచి ఇక్కడికి, అండ్ అగైన్ ఇక్కడి నుంచి ఇక్కడికి. సో దట్స్ వాట్ ఇట్ ఈస్. దట్స్ హౌ యూ కెన్ డూ. క్లియర్, ఐ హోప్. కొంచెం ఇన్వాల్వ్డ్ క్యాల్కులేషన్ చేయండి, బట్ ఎనీవే విల్ డూ ఇట్ టుమారో.
Noted, sir.
Okay, ma. We'll clear today and then we'll see. We'll meet tomorrow. It's sufficient today. We'll meet tomorrow. See you all.